So this lesson is all about graphing relationships. So take a second, read through example 1, and then we're going to talk about which graph best represents it and why. Alright, hopefully you paused it and read through it. So we're talking about leaves falling from a tree. Let's look at the important parts. One day, a gust of wind blows off many leaves. Okay, so let's look at these graphs. Graph A, if your graph is going up, and we're talking about the number of leaves and the time, does the graph going up mean that leaves are falling off of a tree? No. So we know A cannot be it. B could be it, leaves are falling right here, and C could be it, leaves are falling right here. So let's keep reading. Eventually, there are no more leaves on the tree. Choose the best graph that represents the situation. Okay, so every day some leaves are falling from a tree. One day the big gust blows off a lot, and then there are no more. So we need to choose between B and C, which one best shows that. So let's look at B. Leaves are falling, a lot of leaves fall, more leaves fall, and then it ends. C is showing us some leaves fall. In this part, what's happening if your line goes flat? Think about that. If your line goes flat, that means no leaves are falling. But the problem doesn't say that. It says several leaves fall off of it constantly. So C is not the one that works. Graph B is going to be our best option. Let's look at another one. Air temperature increased steadily for several hours and then remained constant. At the end of the day, the temperature increased slightly before dropping sharply. Choose the graph that best represents this situation. Alright, so let's start at the beginning. The air temperature increased steadily for several hours. Well, let's look right here. Is your temperature going up or is it staying the same? Right here in graph A, it's staying the same, so that doesn't work. Same thing in graph B right here. The temperature is staying the same, so that's not going to work. So let's go through graph C and explain why it is the best one. So this is the temperature rising for several hours, and then it remains constant. That's this flat part. It's staying constant. Then it increased slightly, so there's the increase slightly, before dropping sharply, and then it ends with dropping sharply. So for this one, graph C was the best. This you need to write down, continuous and discrete graphs. We're going to talk about the difference. Continuous graphs are graphs that are connected lines, okay? Like you might plot some dots, but you're going to connect the dots, okay? And an important thing to know about continuous graphs is that you can have halves. For instance, height. You can be 5.5 feet. That's okay. Time. You can be walking somewhere and it take you 2.5 minutes or 2.2 minutes. You know, continuous means you can have decimals, you can have halves, you can have parts of it. Discrete are only points, okay? They're just going to be graphs with dots. You're not going to connect the dots. They're just going to be graphs that have dots. And discrete graphs cannot have halves. So like people, right? You're not going to have 2.5 people show up to something. What else cannot have halves? Well, right now, I bought a bag of pretzels. I'm not going to go to the store and say, no thank you, I'm just going to buy half of these pretzels. I either buy the whole bag or I don't buy any, okay? So discrete cannot have halves, continuous can have halves. And again, pause it if you need to write that down, but you need that in your notes. So let's look at these two graphs. One of them is going to be continuous, one of them will be discrete. And it's very easy if you just remember. Here's how I remember it. Discrete starts with a D. Discrete means it's going to be dots, right? They both start with D. Discrete is dots. So this one, the park attendants, this is discrete. These are just lines that are all connected. So this one is continuous. And then it says, write a scenario for each graph. So here's what you're going to do to think about this, okay? First, you need to look if it has a title. This one does. What are we talking about? We're talking about theme park attendance. And then you need to look at your variables. I'm talking about people. I'm talking about years. So I need to have all three of those parts in my scenario. When I'm writing what's happening, I need all three of those parts. So let's look. What's happening to our number of people? hopefully you realize that it is decreasing. They're going down. So a possible scenario, and there's several ways you could write this. I would put attendance. Let's not even do that. Let's put the number of people attending the theme park decreases over the years. Right? Does everyone agree that that's pretty fair statement? The number of people that are attending this theme park decreases over the years. So you notice I included people, I included years, I included that we're talking about people going to the theme park. Okay? So let's do this one. Okay, this one doesn't have a title, so we can really make it about whatever we want. But we have to make sure and include height and time. So I'm going to go through, and here's what's important with continuous graphs. You need to make sure that you're including every part, okay? So right here, how would I write about that part? I would say something like the height stayed constant, right? It's flat, nothing's happening. And then let's talk about this part. And let's go ahead and talk about this part because they're both increasing. But if you look, this part is increasing slower, or I'm sorry, faster than this part. So let's write something like the height stayed constant, then increased sharply. The height continued to increase slowly. And then let's look at that bottom part. What's happening there? The height decreased. And make sure you're talking about at the very bottom. What is your height if it touches the bottom of that? The height decreased to 0 because it hit the very bottom. Okay? So that's a good, basic example. Again, there's several things you could write about this graph. All right, these I want you to, you don't have to write them down, but I want for you to attempt it. See if you can figure out if they're continuous or discrete. Remember, continuous, you can have halves. So height or time or distance, those can have halves. Discrete means you cannot. Okay, so pause it, try these, and then we're going to go over it. Hopefully you tried them, and we're going to go over them, all right? Temperature during the day. Again, I always think, can I have a half? Can I have 88.5 degrees? Yes, you can. So, temperature during the day is going to be continuous. Number of people in school. Can you have half of a person? No, you cannot. So that would be a discrete graph. Car speed during a trip. Well, let's talk about driving. If you're driving in a car, your speed. Could you go 55.5 miles per hour? Yes, you could, which means it is continuous. Height of a candle burning. The height, could it be 3.5 inches tall? It could, so that's continuous. Number of snacks in a candy machine. Now, are you going to go put $1 in and the snack machine is going to cut it in half and only give you half of your candy? No. It's going to give you the whole candy bar, so that's discrete. 10 is a little tricky. I put it on here. I specifically said in dollars. Okay, the amount of money in dollars added to your account. So we're not talking about change. We're just talking about dollars. So can you put in half of $1? No, because that would be 50 cents. And we're only talking about dollars. So this one is going to be discrete. All right, this again I would write down because we're going to start graphing. And this will help you. Variables that will always go on the x-axis are time. Anytime you're talking about time, which is going to be the majority of what we're graphing, it's going to go on the x-axis. Variables that always go on the y-axis are going to be money, cost, distance, height, speed. All of those will go on the y-axis. So let's get to it. Let me move this out of the way. And we will do this. A truck driver enters a street, drives at a constant speed, stops at a light, and then continues. So let's first talk, is this continuous or discrete? Well, we're talking about a truck driver and his distance, how far he's going. So he goes on the street, drives at a constant speed, stops, and then he continues. So, you know, is it going to be dots, or are we going to do a continuous line to show his drive? And hopefully you will think we're going to do a continuous line. So this graph is continuous. What are your variables? All right, this part's kind of hard because we got to think, what are we talking about in this problem? Well, we're talking about his speed, right? Drives at a constant speed. And then the other one's kind of tricky, and I kind of led to it on the last problem. I said what will typically always be on your x-axis for what we're doing? It's time. We're talking about the time that it takes him to drive this path that he's going. Which goes on the x-axis and y-axis? Well, if you wrote down the previous slide, you'll know that the x-axis will be time and the y-axis will be speed. And last up, it wants us to sketch a graph. So important things to know. I will count off if you do not label your graph. So this is your x-axis. X-axis, quick review, is on your bottom. It goes horizontal, and I'm going to put time down here. Your y-axis goes vertical, and that's going to be my speed. Okay, the way that these problems are hard is that you actually have to think. Okay, it's not an easy, I read the problem, I know exactly what to do. You need to think, and I'm going to be very, very picky. I'm telling you straight up. I'm going to be picky when you're doing these graphs because your EOC will put several graphs that just have a tiny thing different, and you got to pick which one is the best. So we got to get really good about reading carefully and making sure we're doing everything we need to do. So we're going to start at the beginning. A truck driver enters a street. So if he's entering a street, what is his speed when he takes off to enter a street? It should be 0 if you're a good driver, right? You don't want to turn on a street. You're going to come to a stop before you turn onto a street. So that means I'm going to start here at 0. Okay, so let's show him entering a street. Now, you got to think of your steepness. If I draw a really steep line, that means he's going really fast. But when you're entering a street, you're not going fast, right? It's going to take you a while to build up speed. So I'm going to make it go a little bit up here. Okay, so he enters the street. He's got to build up his speed, and then he drives at a constant speed. So that's when my line is going to go flat. Okay, so he's driving at a constant speed. Then it says he stops at a light. So what's going to happen when you stop at a light? Well, you're going to go down. Now again, I'm going to be picky. This I'm not going to give you credit for. Okay, yes, you have it that he's stopping, but you're saying in 1 second he's going from, you know, whatever, 35 miles per hour to 0. And it doesn't immediately happen. You have to slow down. So you would put that he slows down to a stop at a red light. Okay? Then he continues. Now again, I'm going to be picky. If you go like this, I'm going to count off a little bit on this graph because you're telling me he came to a stop and then immediately went on. And that's not typically how red lights work, right? Typically, when you stop at a red light, you have to stay stopped for a little while, and then you can go some more. Okay? So hopefully you can see from this, there's lots of ways that you can make little mistakes. So I really need you to slow down, read these problems, and think, does my graph truly reflect what the problem is telling me? Okay? Let's do another one. Small bookstore sold between 5 books each day. Oh, not sold between. Let's just put they sold 5 books each day for 7 days. So is it continuous or discrete? Well, we're talking about books. All right, again, are you going to sell half of a book? No, I hope not. I would not buy half of a book. So this is going to be discrete. What are your variables? That means what are we even talking about? Well, we're talking about books, right? And what else are we talking about? It's typically the words that come after the number. So I got 5 books. My other variable is days. It took 7 days. Which goes on the x-axis and which goes on the y-axis? Well, days is a form of time, right? Days and time, they're the same. So days is going to go on my x-axis, which leaves books to go on my y-axis. And last up, sketch a graph. Now remember, we need to label. So I have days on my x. I have books on my y. Okay, this one is also different because it's giving me numbers. If it gives you numbers, you have to put numbers on your graph. This problem that we did before, it didn't give me any numbers, so I could just make it up as I went. This gives me numbers. I'm talking about 7 days. So I'm going to put 1 day, 2 days, 3 days, 4 days, 5 days, 6, 7, right? And we're going to put the number of books that are sold. So they sell 5 each day. So 5 on the first day, 10, 20, 30, nope, sorry, whoa, what am I doing? This should be 15, 20, 25, 30, 35. Okay, now let's graph it. Let's think in our head. Could we have 0 days? Yes, we could. That would be present time, or like when the bookstore first opened, and they could sell no books. Okay. On day 1, they sold 5. On day 2, in 2 days, they had sold 10 books. 3 days, they had 15. 4, they had 20. 5, they had 25. 6, they had 30. And 7, 35. So they sold 5 books each day. So total, after 7 days, they had sold 35 books. Now, you need to say, is it continuous or discrete? Because if it's continuous, I need to connect those dots. If it's discrete, I can just leave the dots the way they are. And it is discrete, so I'm not going to connect the dots. I'm just going to leave my graph like this. Okay? Next up, Jamie's taking an 8-week keyboarding class. At the end of each week, she takes a test to find the number of words she can type per minute. She improves 3 words each week, and she starts at 8 words per minute. Continuous or discrete? Well, if she's doing 3 words each week, we're not saying 3.5, we're not saying 4.5, blah, 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 blah. So this one's going to be discrete. We're not doing half of a word. What are your variables? Well, we just said words, right? We're talking about words. And we're talking about, what are we doing? An 8-week keyboarding class. So we're talking about weeks. Well, again, I told you most of the stuff we're going to do time. And weeks is a form of time. So that's going to go on your x-axis, which means words will go on your y-axis. And then finally it says sketch a graph. So we got weeks. We got words. And we're talking about 8 weeks. So I'm going to go to 8. 1, 2, 3, 4, 5, 6, 7, 8 weeks. She starts at 8 words per minute and improves 3 words each week. So here's an important part that people do every year. And this is not going to work, and I'm going to ask you why in a minute. If I started with 8 and then went up by 3 to 11, and then went up by 3 to 14, that graph is not okay. Look at it and see if you can think why that graph would not be okay. I'll tell you why. Because this gap right here is telling me it's 3. This gap right here that you did to get from 0 to 8 is not 3. To get from 0 to 8, you went up 8. So to go up another 8, you should have your next one at 16, which doesn't really make sense for our problem. So I'm not going to start at 8, okay? I'm going to start at, what do I want to go up by? I think I'll go up by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And let's graph this. So, okay, things we need to think about. Am I going to start at 0, 0? Hopefully you can say no. I'm going to start at 8 because that's where she started, right? She started at 8. And then after 1 week, what is she going to be at? Well, 8, and then she improves 3 words, so we're at 11. So I'm going to go to 11 and put a dot. And then 3 more. It's going to be at 14, 17, 20. Oh, I'm going to have to go off my graph. And then you would keep graphing. 23, 26, 29, 32. Okay. And last part, you should say, do I want to connect the dots or not? Well, it is discrete, which means you do not connect the dots. Okay, last up. Henry begins to drain a water tank by opening a valve. Then he opens another valve. Then he closes the first valve. He leaves the second valve open until the tank is empty. Whoa, there is a lot going on here. So let's start with basic. We're talking about draining a tank. So am I going to connect the dots on that, or am I going to leave them as just dots? Well, hopefully you know it's continuous. We're going to do a continuous line to show that water level. Variables are going to be the water level and time. If you ever don't know, time is a safe bet. So the x-axis is going to be time. The y-axis is going to be the water level. And let's graph. So I got time and I got water level. So if I'm talking about draining this water tank, where's your water going to start? Is it going to start down here at 0, or is it going to start up high? It's going to start up high because we're draining the water. So he opens a valve. So water is going to go down, right? Then he opens another valve. So let's think about this. If 2 valves are open, is your water still going to go down, but is it going to go down slower or faster? If you have 2 valves open, it's going to empty out faster. So I'm going to make it steeper because 2 valves are open, right? Then it says, then he closes the first valve, which means it's still going to go down, but just not as fast. And he leaves the second valve open until the tank is empty. So I'm going to keep going until my tank is empty. So that's that last graph. If you'll go try those graphs on your own and let me see them when you get done. Thanks.